Hi, this is Maggie. In this video, I'm going to talk a little about object persistence and garbage collection. To do this, I'm going to create some instances of this shopping list class in a program. I'll import shopping list at the top with from shopping list import star. Now I'm going to put all of my code in a main method. And invoke it. So I'll make two instances, or objects, list1 and list2, to give them very uncreative names. And just so we can distinguish them, let's put the boole on list1 by invoking the addItem method. And we'll put scallop maki on list2. Short lists. Now, each of these objects consists of two lists. They are internally referenced as items and all items. As long as I have variable references to the objects, all of the object data exists. So once again, you can think of the reference list1 as self with items and all items when we send a message to list1. And you can think of list2 as self with items and all items when we send a message to list2. I've made a representation of this in Visio. So on the left, I have stack memory, and there is a frame for the main function with the local variables list1 and list2. These reference the two objects in the heap, list1 and list2, which each have the two lists, items and all items, and we have the values stored in those lists. Now, what is meant by persistence is that this object exists on the heap. We know that the references list1 and list2 exist while main is executing, and they do not exist when main is finished executing. What about the objects in the heap? They exist as long as there is a variable referencing them. In fact, Python keeps a count of how many references there are to each object. And once it reaches 0, it means the object can't be used because there is no longer anything that has a reference to it, and it's marked for garbage collection. Garbage collection is Python's way of cleaning up unused memory, so your program doesn't waste memory with old, unused data and potentially run out. When Python periodically performs garbage collection, it takes all of the memory that is marked for garbage collection, that is no longer being used, and either marks it as available for reuse or gives it back to the operating system. So let's modify our program a bit. And I'll create a list3. And I'll have it point to list2. So list3 equals list2. This doesn't copy list2. It just copies the reference to list 2. So now list 3 and list 2 point to the same location in memory. And I'll add that to the drawing. So list 1 has a reference to it, and list 2 has 2 references to it. Now let's make a new object using the list 2 reference. So list 2 equals shopping list. Now here's what that looks like in memory. The old list 2, I've now renamed it list 3 in memory, and it's still hanging around and not marked for garbage collection because list 3 still references it. And here we have the new list 2, which has an empty shopping list and an empty list of all items. Let's make a fourth object using the list 1 reference. So list 1 equals shopping list. And before I show you my drawing, we'll look at the current drawing and pause the video and sketch what this now looks like. Now here's my drawing. List 1 now references this second new empty list, but the old area referenced by list 1 has no references, so it will be marked for garbage collection. Our program has no way to access or use it. It's gone. And when the main function is no longer executing, the frame on the call stack will be destroyed, along with all of these references. And then all of these shopping list objects will be marked for garbage collection. And that's really it. The cool thing about this that you might have noticed is I created 4 objects and I have only 3 references. I could create a lot of objects with only 1 reference, as in this image mover program, where I create 3 image objects in a list. The only reference to them is the list reference, and I could create 100 there. So the cool thing about objects is we can create them as we need them, and the space is allocated. We don't need to know in advance how many we might need. Imagine a drawing program like Visio here. There's no way the creators of Visio know how many drawing objects I'm going to create, how many bits of text or clouds or arrows or boxes, but I can continue to create them because they're dynamically generated as the program is running. For practice, review some of the object-oriented programs you've written so far, or programs from the text or video examples, and count the number of references to each object and determine when the objects are marked for garbage collection.